Good evening. Welcome to the NYNJPA weather educational video for November 6th, 2013. Today we're going to talk about what to look for on the model guidance when you're forecasting a winter storm, or in this case, not forecasting a winter storm. I'm going to explain why I'm doing this video today and not another day. I'll probably redo this video again on another day when there's actually a winter storm threat. And the reason why is because it never fails. Every year we have, or almost every week during the winter, we'll have one model that spits out a run that shows a blizzard, a nor'easter, or a snow event, but a trained meteorologist will know that this is complete nonsense, that the GFS, for example, is off its rocker, or there's an error in the model guidance, and you're able to pick it out real fast. But those of you who aren't trained in meteorology, well, how would you know? Well, unfortunately, there's always some in the media that, well, they know better, but they don't, and they want to get as much drive as far as their ratings or web hits or whatever you want to call it. So let's talk about what I don't like about this setup for Wednesday, November 13th, 2013 at 12Z, which is about 7 a.m. in the morning. The GFS produces a little snow event, or at least that's what it looks like when you're taking a look at 850 millibars. You're taking a look at this, and then you take the model extrapolation, and it produces a nice little heavy snowfall over eastern Pennsylvania. Why is this not realistic? Well, for one, let's go back to, let's say, Wednesday, or yeah. It's about 156 hours on a Tuesday night. You have this strong disturbance, and what are we lacking here? We're lacking any type of strong high latitude blocking over the northern Atlantic. That's important because it needs to slow this disturbance down. What we have right here is what's called a progressive weather pattern. Even worse, for all you snow lovers out there, is that this ridge is being knocked down pretty quickly. So as we move to 108 hours, which is on Thursday night, or should I say Wednesday night, what we have here is, yes, an upper level low that's trying to phase itself together. Now, this is a warning sign in the GFS. When you see all this red becoming one big blob, that's called overphasing, and it's not likely to happen. But the GFS likes to do it quite a bit, even with its improvements. But take a look at the Atlantic. There's nothing to block up this disturbance from just heading straight out into the Atlantic. So the idea that's going to linger and produce heavy precipitation here is a little bit unrealistic. Even more importantly, we don't really have much of a ridge here. We have a lot of strong disturbances digging into the western Canada and portions of the Rockies. We have more disturbances coming in off the west coast. This pattern is almost zonal in nature when you look at 250 millibar winds. We do have a strong ridge, so we're keeping reasonably cold air in place. Now, this is early November. Now, this scenario here, let's just say that we did have high latitude blocking with a nice big upper level low here, a nice ridge building into eastern Canada. This cold air would be what's called marginal in late December and really not all that cold in November. It's chilly, but it doesn't support snow. This is one of the big fallacies and big mistakes we see in meteorology when using those snow maps from the GFS, and we all know where those come from. They take 850 millibar temperatures and they take the precipitation and say, hey, it's below freezing, therefore snow. That isn't always the case. You have to consider the type of air mass you're dealing with, in which in this case it's an air mass that's influenced from the Pacific, and we know that because we have a very strong Pacific influence with this type of weather pattern. So the air mass is going to be modified. And we also know that given the time of year, that these 850 millibar temperatures typically still correspond to above freezing temperatures at the surface. So clearly, it's going to be a little bit warmer along the coast. And oh, by the way, during this time of year, you have to watch out for the waters here, because any type of easterly flow, like what we see here with the pressure here packing itself in here like this leads to an easterly wind, and that means that we're transporting warm Atlantic air from the Atlantic into the coastal plain, which will keep our temperatures in the 40s. So this is a rain event. For the higher elevations, if this storm somehow amplified as quickly as it does and somehow slows down without any type of high latitude blocking, well, you could see some snow over the highest elevations. But again, one of the problems here with this whole setup is that this pattern is what you call zonal. It's going from west to east. It's moving pretty fast. You have one strong disturbance in that flow, and that's pretty much your storm in the GFS. Let me give you a hypothetical. Let's go to 384 hours. Okay, now I'm not saying you use this for a forecast. Do not get me wrong. But let's say that this was at 120 hours, okay? And what you would have here is a strong ridge over Greenland, a nice strong upper level low over portions of southeastern Canada. This is what you would call a blocked up pattern, okay? And then you have your disturbance cutting underneath that block. And of course you have a ridge right around Montana. Now, if you want to find out whether or not you're going to get a winter storm along the East Coast, look 2 days beforehand before the storm, and if you have a ridge axis right around Montana and Idaho, that is a perfect setup to allow a storm like this to dig, intensify, and move right up the East Coast. Combined with the factors of, let's say, high latitude blocking in the Atlantic to slow down this whole pattern. So this is what I want to look for. Some sort of rough combination of this setup with this ridge around Montana and Idaho and a amplified 500 millibar pattern. And also it wouldn't hurt if you have plenty of cold air and it's actually the right time in the season. Now there are scenarios where you can get heavy snowfall in October and November. Sometimes what you would have, for example, is a very intense upper level low to drag this cold air down to the surface. In this case, we do not have that. You need a very amplified 500 millibar pattern, a very intense storm that is able to sit in place and give the atmosphere enough time to draw that air from 850 and 700 millibars down to the surface to transition precipitation to the coast. Or should I say, transition precipitation to a frozen precipitation down to the coast or over the interior. Now, let me show you the European model guidance, which is not as impressed in this scenario. What do we have? We have a very similar pattern to what's seen in the GFS, but the European model guidance is not as, well, impressed with the storm potential. At 850 millibars, you have a basic positively tilted trough. Same thing at 500 millibars. It's a progressive pattern. You could see a wave of low pressure develop along this front, but this isn't a scenario where you have a strong storm. Could be a nuisance type of event. Let's say some light rain with a little bit of mixed precipitation over the interior with this type of setup. But this isn't a major storm, and it certainly isn't anything worth to go crazy about or make, let's say, snow map posts from the GFS model guidance several days out. It's a benign pattern. If you see this, it's impressive. It's something to consider. It's something to say, we should watch this and see how it evolves. If you see this, it's not. And again, look what the GFS does here. It tries to combine all the disturbances and produce this insane storm that draws cold air in, precipitation, and tries to phase every disturbance known to North America into one little nice ball. Not going to happen. At least not this time. So that is your educational video for this week. I hope you enjoyed it. I hope you learned something here. Of course, I'll always have more educational videos over the next several weeks and months ahead. I'm your meteorologist, Stephen DiMartino. Thank you for watching and have a wonderful day. And stay safe out there and don't stay up till midnight to watch these models, please. It's not that time yet. We'll get there.